Hi guys, I want us to redo the FEA analysis in Creo, and today on our first day we're going to start from a basic. Once you open Creo, this is what you see. You just go to new. It is a part. You're using a part, but I'm going to illustrate in another video how to use an assembly. But for now, as a part, you can give it maybe FEA underscore 1 or underscore first, whatever the name you need. The template that is used for part modeling is a default template, but you can select yours. For me, I'm going to use default. You say OK. Once you open the part environment, this is what you see. These are the three data planes, right, top, and front. And you can see. If you want to hide them and show, just hide and show here. And today I want us to model a part, the new perform FEA. I want to model a part on this plane that is top. If you select the top plane, you can see this toolbar appears. You can see we have a sketch. We have the common features, that is the extrude and revolve. You can also add a plane relative to this plane, an axis, data points, or coordinate system. We can hide it and show. But for now, I want to sketch on this plane. As you can see, the plane still remains isometric, but I want this plane to be parallel to the screen. Therefore, you just select this one here. You can see this icon. The name should appear. If you put the mouse on this icon, you can see sketch view, orient to the sketching plane parallel to the screen. Then I want to model a center rectangle. You can see here we have line, a rectangle, and a circle. Just on this drop down, you can select center, or you can use a shortcut keyboard G. But for now, I want to select center. Then go to this point here, like that. Then I want to go to dimension, select dimension here. This one to be 100, maybe this one to be maybe a 60. Just want a simple model for now. Then you can extrude. You can say OK. You see now the sketch is in green, but you can change all these options under the file options there. Let me hide the plane. This is my sketch. If you select your sketch, you can see this toolbar appears again here. I can use this toolbar to extrude, or I can use this one here. Then this is the value of 80. If you select this dot and drag it, you can see this yellow dot, this value is changing. You can either drag up or go the other side. You can do that. Then you can change this value here, or can go here to change. Therefore, I can say maybe I want to use 20. Then say OK. Okay. If you want to edit, just go to the extrude and select this second icon, edit, and make it maybe 10, like that. Now I'm using 10. Then say OK. I want to drill some mounting holes here on top. What we can do on that is I can use either I can use hole command, or I can extrude. Let me just extrude cut. In some videos I show you how to use a hole command. Then you can go to the orient sketch, this here, orient the sketching plane parallel to the screen, again center rectangle, like that. Then select I want this to be for construction. You can select construction mode. You can see construction mode, then select center rectangle, like that. Then go back to the normal mode, select a circle here, another circle here. Just watch and see. You can see this circle, there's an icon that says they are equal. Now if you allow. Now this means these two circles are equal. You just need to dimension one. The same case here, also here the same case. Then you just need to dimension one circle here to be maybe 10. 10 is okay, and you can now extrude. You can say okay first, then select your sketch here, then extrude. You can see now is adding material, but if I want this material to be removed, just go down and say okay. You can see. You can also define the depth to which we are going to extrude cut. Sometimes it's good to say up to a certain value. You can see now we are saying 43. If you select here, you can say draw all, so that in case this height of the extrude changes, the circle will always be draw. Then you can go back to, let me select the front plane and show it. I'm just hiding. Let me show the planes here because I want to sketch onto front plane. You can select front plane here, sketch, orient, and I want to have maybe a line here like that, maybe, or like that, like that, like that, like that, like that, and like that. Let me do some editing here. Oops, let me redo that by Ctrl Y. You can undo or redo. I want to delete this and delete this. I want to another line. You can go straight again here, then go to this one here, and then go back to make a complete loop. Then I want here to have I can select an arc here, 3-point arc. This point, instead of a 3-point arc, let me select center edge. These are center edge. Just select one. You see, when you select an arc that is a center edge, you have to start by selecting the center, then edge. If you go like this, the circle is like this. If you go the other side, it becomes counterclockwise, as you can see, like that. Then this one I can delete it quickly. We can now dimension this one here. Also, I want to add another arc here using the similar method. Select they are called center edge, like that, edge and edge, like that. Then delete this. As you can see, we have a red icon. This means this one and this one are not touching. Therefore, you can see they are not coincident. You can select coincident this point to this point. That becomes highlighted. Now you can change your dimensions. This one to be, this one here to be 10. This value to be 10. Oops, okay. This to be 5. This to be 30. I want this and this to be equal. Select equal, this and this, like that. Then I want this guy here to go a little bit inwards, or basically I want this. Let me just dimension here first. 120. Then this one is to be maybe 70. This is 5. This one is 10 and 10. That's fine. But this one here to be shorter. This one to be shorter here. Basically, maybe let me see, 1. Okay. Then this to be longer, maybe 15. It's just a quick one sketch just to illustrate some concept of FEA. Here can be 150, That's too big. I can go 120 also. Let me go 130. Yeah, you can just put your own dimensions here because I want us to have such this shape. Then you can now say okay and select this one here and extrude. I want to go on both sides, not on one side. If you select here, you see this one here, you can say symmetric, or you can go here and say symmetric of 10, like that. Okay, you can see now. You can hide your planes. Then I want to add some fillets. Then we go to the F2 actual FEA. Fillets, you select round. You can first select the edges you want to add a fillet. You have to press Ctrl. You can first select edges you want to add a fillet, then say round, maybe to 5, and say okay. Same case applies to this edge here, round maybe to 10, and say okay. You can edit this round here. If you see here, we have sets. Sets means it is where you are selecting your edge. I have set 1 of this. Now I can add also this edge to the set 2. And the funny thing is, the good thing is you can edit these things, these fillets separately. Because now you can see set 1 has 10, set 2 has 5. You can add a new set and select another edge. Basically, you can use one command to select to fillet everything. You don't need to use round 1 and round 2. This is a point to note. Okay, like that. Then if you want to go to isometric or standard view, just select like that. Now this one is my isometric. Now this is a part we are going to perform as FEA on this part, basic FEA. Now for you to perform basic FEA, you can see we have model, analysis here, we have live simulation. We are going to go to last one, that is application, and say simulate because you want to perform simulation, that is a finite element analysis of this part. The first step is us to define material. Of course, for you to perform analysis of a part or component, you need to define the material, because from the material that is where we get the data that is needed for FEA. That is tensor strength, position ratio, all those parameters. If you go to the under home tab, you can see we have material assignment. If you select material, you go to properties. Because you don't have any existing material here, you just go to there. You can give a name, the name you want, that will appear on your tab here. And for the material, if you go to more, you can see you have a fluid for those who perform CFD, but for us you can select legacy. These are the materials that are in the library. And from now I'm going to use steel. Let me use steel, this one. Then bottom here you select a material must be selected from the list of the materials in model. Okay, if you double click this material, you double click material first, it will appear here. You can see these are the materials that now go to the model. Then you don't select from here, you select from here. Select steel, then select, then say okay. If you have this one is a little bit whereby the material is the material properties vary on a certain axis. That's when you use the material orientation. You can see now I have the material assignment here. You can see material assign 1. This name, you can rename the name as per the name you need or not. Step 2 is for this part, I want to fix these 4 holes. I'm assuming I'm bolting these holes on a certain maybe on a wall, and I want to apply load on this face downwards. And you can see this is the symbol for the material sign. You can see it's just a graphic visual representation that assists you to determine whether you have defined your material. Therefore, the next is to go to the displacement. Under the displacement, we can give a name. Maybe the mounting, you can say maybe mounting holes like that. And we need to fix all these holes at the translation such that the surfaces here they will not translate. This first means free, second means fixed. That means you can define, we can say this hole can move maybe 1 mm. You can prescribe the initial movement, especially for the bridge analysis, whereby when the bridge is at the high temperatures, the bridge can expand by a certain amount of value. This way define it is free to move up to maybe 5 mm at the translation. But rotation, because it's a 3D, once you define translation, you don't need to define rotation. Then when selecting the surfaces, you can either select individual surface like that using the individual option here, or you can use a boundary. All previous selected will be yes. You can use boundary, or you can use intent. Intent means it will select everything that was used by using a certain command. For example, these holes I used extrude, I think extrude 2. Therefore, if you select one, automatically selects everything by using the intent option, because now it is looking for the extrude 2 surfaces intent. Then you say okay, the name is invalid. You should not have a space. Mounting holes, Creo doesn't allow space when naming your when renaming your features. You can see now this one is everything here is fixed. And next is now to define the force on this face. You see here you have the force moment. You can define your load again here, but here you don't need to select intent. I want to use an individual because I want to select an individual surface. This surface, you can see I'm selecting this individual surface. And as you can see here, under the force direction, you can either have direction vector or direction points. In future videos, I'm going to illustrate how to use direction vector or direction point. But for now, we are going to use components. We can either have along x-axis. You can see x-axis is like this, y-axis is up, z-axis is like this. Therefore, we need to define along y-axis, and my value, I want to use Newton's meter. I want to use Newton's here, and force is Newton's, moment is Newton's meter. Okay, and I want to define my value along y-axis. I don't want to assume this part is carrying maybe 50 kgs, that is a 500 newtons on this face. If you preview, you can see now the arrows are pointing up because y-axis is pointing up, and I need y negative. You have to use a negative sign. If you preview, everything now is pointing downwards. This is very important to ensure that you preview to see the direction of your force. Then you can say okay. Before I run analysis, this one is a basic one. The reason why I'm not going into deeper on deeper details on how to use these other features. If you go to the refine model, you go to the autogen, it will automatically generate some p-type mesh. just to view how they look like. As you can see, my mesh is rough. Okay, but for now we can work with it like this, but we'll discuss on how to refine your mesh. But for now it's fine because it's a quick FEA. Close this. Do you want to save the mesh? I don't know how to save the mesh. I just want to review the mesh. Next, if you go back to home and you go to the analysis and studies here, home, analysis and studies, here is where now you define what you need. I now want to run static. Sometimes you may want to run a time dependent dynamic analysis like frequency, random frequency for the vibration. These are the at least advanced. You can also do some buckling and some fatigue. We can do these ones later, but for now it's a basic one as new static analysis. You can give your name here. For the method, you can either use quick check if you want to do a quick check here, or multi-pass or single pass. I'm going to select a single pass. You can go to advanced control, but for now just select single pass. And next is you can either select run or this one here, green flag. Output files already exist. Maybe they are somewhere there. Just say yes, I want to delete them. Do you want to run interactive diagnostics? This is whereby in case there are some errors here, you can be able to see them as the simulation runs. If you select yes, you can see here it was very fast. You can see simulation diagnostics here. You can see this table because we said we want to see. You can be able to see this table here. And for now, I don't need to see it. Just close it. Then if you select this analysis one, you can go to the results here, or you can go to results here, dialect. Okay, you can give the names you need here. For me, I want for the quantity, I want to see displacement first, and I want to see the displacement in millimeters, and I want to see the magnitude. I can select along y-axis if I want, but let me see magnitude in case the displacement is diagonal. Then for the display options, I want to see deformed. Okay, I want to see overlay and deformed to see the differences between the deformed and undeformed. Then for the transparent overlay, we can decide to make sure that once the overlay one is transparent, we see what happens. You can select 15 here. I want to animate also. Yeah, let's first see this, what we are going to see. You can see what happens here is this one is undeformed, this one is deformed. Okay, if you go back to open here, oh, sorry for that. I wanted to see if you go to edit, you see these frames here. You can maybe go to 20 like that. Let's see, yeah, to reduce the speed. You can see now. If I go back to edit, if you deselect transparency, you see now what happens. You will only see the lines here. I think this better. I think I like this. You can see now from the front view, but for some reason it's very shouty, very bright. If you scale here, for me I like using 10, not 15. You can play with these parameters until you understand what is happening. You can also use continuous tone. Just see the continuous tone. The other one was discrete. You can see how they look like, these tones here. Let me just deselect here. And okay, that's how you perform a quick FEA This is a basic one to determine the displacement when you have a load of 50 kgs, and you can see the value here. Okay, let me say thank you for your time. I'll create another video, at least more advanced a little bit. Share the video, like it, and see you. Thank you.